In Learning Target 1B, I can identify transformations that have been applied to a parent function. We're going to start with the vertex form of a function. The vertex form is given as f of x equals positive or negative a times the quantity x minus h to the nth power plus k. First thing we want to do is identify the parent function by the value of n. An example here is if n equals 2, then our parent function would be a quadratic because we would have the quantity of x minus h squared. If n were equal to 3, then the parent function would be a cubic because we would have the quantity of x minus h to the third power. Sometimes there isn't an n, but a symbol in place of the parentheses. An example of that would be f of x is equal to positive or negative a times the square root of x minus h plus k. Notice that the k is not under the square root symbol. This would, of course, be a parent function of. And another example would be f of x equals plus or minus a times the absolute value of x minus h plus k. Again, notice that the plus k is not within the absolute value symbol, and this parent function would, of course, be absolute value. Okay, so the transformations work the same way for all of the parent functions. It's recognizing what the parent function is and then recognizing what the transformations or changes to the parent function are taking place. First of all, if there's a negative sign in front of the a or in front of the parentheses, it means that the function has a vertical reflection. The function reflects over the x-axis. There is a vertical reflection there. If the a itself is a dilation of the function, if the absolute value of a is greater than 1, then the function stretches, so it gets skinnier or taller. If the absolute value of a is less than 1, then the function shrinks. It gets wider. It gets broader. The h is the horizontal shift along the x-axis. The minus sign moves it backwards. Example, if f of x equals x plus 2 the quantity squared, this function says plus 2. So all of the points for this quadratic parent have to move 2 spaces to the left because you're actually subtracting a negative 2 to get that to be positive. So it moves 2 spaces to the left. The k is the vertical shift along the y-axis, moving up or down. An example here, in this example, will include many of our transformations that we talked about. Okay, first we want to see our function f of x equals 3 times the quantity of x plus 1 cubed minus 4. We want to identify the parent function. So the parent function is, and hopefully you said cubic. Okay. The a value is what value? Okay, hopefully you said 3. So the function is, well, 3 has an absolute value greater than 1, so the function is stretched. Okay. The h value is negative 1. Because a negative 1 is a plus 1. So the function moves left 1 space. The k value is, hopefully you said negative 4. So the function moves down. Because it is negative, it moves down 4 spaces. Our last example, our f of x is equal to a negative square root of x minus 2 plus 3. We identify the parent function as a hopefully you said the square root function. There's a negative sign in front of the symbol. So that means we have a vertical reflection. The 2 under the symbol means that we have to shift how many spaces? Hopefully you said 2. And are we going to the right or to the left? We are going to the right. And the 3 is a shift how many spaces? Hopefully you've said 3, and this is a positive 3, so we are shifting up.